Today's topic is solving quadratic equations by graphing. This is lesson 3.2, and the two major objectives of today's lesson is obviously we want to learn how to find the solution to a quadratic equation using graphing, and we're going to talk about what that solution looks like. And then in some cases we're going to have to estimate solutions, and we're going to look at a problem involving an estimate in between two integers. So let's get right into it. We're going to follow up on what we did in lesson 3.1. We need to sketch the graph of this, if it were in function form, f of x equals x squared plus 6x plus 8. So let's just think of it as a function, and let's sketch the graph. So just to repeat the steps that are involved, we're going to identify the y-intercept. That's the constant, in this case 8, and I think I'll just put some points on the graph as we go. Let's identify where we have symmetry. What is the equation for the axis of symmetry? And to find that, we do the opposite of b over 2a. So in this case, that's going to be the opposite of 6 over 2 times 1. And hopefully you can see that that's negative 3, 6 over 2, and what is the opposite of that? So the AOS line is x equals negative 3. So I'm just going to draw a dotted line to indicate the AOS. Alright, the vertex has to be on that line. The vertex has to, of course, have the x-coordinate of negative 3. So how do we find the y? Well, we go back to the function and we just input negative 3 for x. And we see what comes out. So what comes out will be 9 minus 18 plus 8. Negative 9 plus 8 is negative 1. So the vertex is the point negative 3, negative 1, which is right there. Okay, because of symmetry, we can go ahead and get another point opposite of this y-intercept. So 3 units to the left of the AOS will be a corresponding point. And so now let's work on filling in the rest of our graph. And in cases like this where we know we're going to be crossing the x-axis twice, we want to be as exact as possible. So I'm going to fill in, I'm going to do 2 inputs. Typically we say 5 points is enough, but in this particular case I want to do a pretty exact graph because I want to know exactly where I cross the x-axis, because that's going to represent the solution to this equation using the graphing method. We're really interested in if the graph crosses the x-axis, then where. So I'm going to do an input of negative 1, so I can fill in right here. So if I do negative 1 input, that would be 1 minus 6, which is negative 5, plus 8 is positive 3. So the point negative 1, 3 is on the graph. That means a corresponding point is also on the graph, which is negative 5, 3. And then let's do another input for this value of x, negative 2. If I input negative 2, I get 4 minus 12, which is negative 8, and negative 8 plus 8 is 0. Okay, so negative 2, 0. That means the matching point, corresponding point, negative 4, 0. So this is the graph of the function. And when you're asked to determine the solution of a quadratic equation using the graphing method, I mentioned this earlier, you're essentially saying, all right, what are these x-intercepts? So I got 2 solutions. I'm crossing the x-axis at 2 different places. My solutions are x equals negative 2 and x equals negative 4. And that's our final answer for example number 1. Example number 2. Okay, this time you'll notice that we're not going to be able to tell exactly where we're crossing the x-axis, so we're going to do an estimate. Okay, but let's just go ahead and work through this. Once again, let's go ahead and plot the y-intercept. That's always an easy point. Y-intercept is 2. Let's identify the equation for the AOS. X equals some number, opposite of b over 2a. So that's going to be the opposite of 6 over 2 times 1, which again is negative 3. So I'm going to draw x equals negative 3 as the AOS. Alright, the vertex. Well, I know it's negative 3 something. To know what the y is for negative 3, just plug it in. And be careful if you're using your calculator for this. Make sure you put parentheses around negative 3. Okay, negative 3 squared is 9. 9 minus 18 is negative 9. Plus 2 is negative 7. So the vertex is on my AOS. It's negative 3, negative 7. Okay, and once again I can match up this y-intercept. It's the corresponding point is 3 units to the left of the AOS. Alright, so let's fill in the spaces. So let's let x be in our little table. Let's do an input of negative 1. Okay, if I input negative 1 in for x, I get positive 1. Negative 1 squared is 1. Minus 6, that's negative 5, plus 2 is negative 3. So negative 1, negative 3 is on my graph, and so is this point. Now let's do an input of negative 2. Negative 2 squared is 4. And when you do 6 times negative 2, that's negative 12. So 4 minus 12 is negative 8, plus 2 is negative 6. So negative 2, negative 6 is on the graph. So is this point corresponding to it. And now we can connect the dots and graph our parabola. Well, not quite as easy to tell what the solutions are. In fact, the solutions are going to be decimals because they don't fall exactly on an integer representing a grid mark on the coordinate plane. So this is where an estimate is going to be needed. We just need to identify in between what two x values would this point fall. So we're going to say between, this is x is negative 5 and negative 6. Okay, we're just going to say in between these two integers. And then over here, this x value is between 0 and negative 1. And that is all you have to do when you come up with a solution that isn't an integer solution. We're just going to state the consecutive integers that our solution falls between. All right, and that will take care of example number 2. Example number 3, another scenario. Let's go ahead and get the y-intercept. That's 9. The AOS equation. Okay, so opposite of b, here's b, here's a, it's 1. Opposite of b over 2a. Once again, we're at negative 3. We're stuck on x is negative 3. Alright, so I'll just go ahead and draw this to show we're going to have symmetry around this line. What's the vertex? Well, the x-coordinate's got to be negative 3. Let's see what the y-coordinate is when we input negative 3 back into the function. Do you see that we're actually going to get 0? 9 minus 18 is negative 9, and negative 9 plus 9 is 0. So the vertex is actually our x-intercept. And let's just go ahead and connect these dots. Okay, so in this case we'll just do one input. We know we're not going to be crossing at two different places, So let's just fill in. You can choose either -1 or -2. I'm going to go -2. I like to be as close to the AOS as possible. So let's see what comes out if we input -2. -2 squared is 4. 4, that would be -12, is -8, and -8 plus 9 would be +1. So -2, 1, match it up on the other side. And for cases like this where you know you're not going to cross 2 times, you can just go back to what we did previously and just use a total of 5 points, the vertex and then 2 points on either side of the AOS. So once again, the solution is the x-intercept, and the x-intercept in this case is -3. So that is my solution for problem number 3. Okay, let's look at another possibility. Well, first of all, I notice a problem here. This equation is not set equal to 0, and that needs to happen first. So first step is I'm going to add 8 to both sides. Alright, now I'm back into my normal routine. Y-intercept is going to be 12, the constant. The AOS equation, x equals something. It's the opposite of b, which is -6, over 2 times a, which is going to be 2. And it's the opposite of -3, which is +3. Well, at least we got over on the other side. Okay, little dotted line to show the AOS. Now I can match this point up, 3 places to the left for the y-intercept, 3 places to the right for the match. Let's find the vertex. Well, I know it's got to be 3 something. Let's see, what do we get when we input 3 into this red equation, the one that's solved for, that made equal to 0. 9, 3 squared, 9 minus 18 is -9, and -9 plus 12 is 3. So I get the point 3, 3 as the vertex. Well, right away, if this parabola opens up, which it has to, since the number in front of x squared is positive, it's got to open up, and it's got to open up from this vertex. So there's no possible way that this parabola is going to cross the x-axis. So in cases like this, this will be enough. If you just want to go ahead and draw the parabola, since we're not going to cross the x-axis at all, we're going to interpret this as no real solutions. I don't want you to say no solutions, because in the next lesson we're going to talk about imaginary number solutions, complex number solutions, using a special number called the number I. We'll save that for tomorrow's lesson, but for now I just want you to say in cases like this that there are no real solutions. We don't cross the x-axis at all. And then finally, the last homework problem example, you're going to do this 3 times, problems 30 through 32. You're going to be given a table of values, much like this. Here are your x coordinates, your inputs. It's represented as f of x, which you can also think of as y. These are your outputs. And here's the thing, when you're looking not at a graph, but you're looking at a table of values that represents what would be on the graph, here's how you can tell the location of zeros. And that's just another way of saying x-intercepts. Okay, you can just use these terms interchangeably. Solutions to a quadratic equation, all the same thing. So here's how you can tell the location, at least an approximation of where an x-intercept is. I want you to pay attention to, as the x inputs, the x coordinates are changed, notice what happens right here in the y's. Do you see how we went from a negative, 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 all of a sudden we changed signs? Okay, so that indicates between x is -1 and x is 0, we have a 0, we have an x-intercept. You can think of it this way. All right, just do a little rough sketch. And where is the point -1, -1? Well, that's down here in quadrant 3. Well, the next point over is the point 0, 4. We'll just say it's up here. Well, to get from -1, -1 to 0, 4, we had to cross the x-axis, and that's what a 0 is. It's just another way of saying an x-intercept. So one of my zeros, and we're going to state this as between x equals -1 and x equals 0. Okay, stated in terms of the x values. Okay, you keep on going to the right, and you notice the change of sign happens again right here. We started at 3, so this time you can think of it this way: 1, 3. Just give you a little rough sketch so you can look at something. Here's 1, 3. Well, 2, -4 would be down here. So to get from one to the other, you had to cross the x-axis. That's what an x-intercept is. So we have another 0 between x equals 1 and x equals 2. So just pay attention to those sign changes, and that indicates where you're going to have a 0 of a function. All right, so I hope that helps. That is the conclusion of Lesson 3.2. Work hard on it. Do the homework well. If you have any questions, you can email me or see me in academic support.